So we're going to review complex numbers, which you learned about in Algebra 2. Complex numbers are numbers that have a real and an imaginary part. So let's first talk about an imaginary number. In the most basic form, x squared equals -1 is going to result in an imaginary answer because that has no real solution. Because x squared means x times x, which means something times itself has to be a negative, in this case a -1. Well, if we let x be a positive number, a positive times a positive is going to make a positive. That's not going to get my -1. And if I let x be a negative times a negative is still going to result in a positive number, which, again, won't make my -1. So this is where the imaginary piece comes in. So we call the square root of -1 I. And we will talk more about this later, but I squared thus is -1, and that comes from I times I would be equal to I squared, and that equals the square root of -1 times the square root of -1, which makes the square root of -1 squared, and the square and square root undo each other, and we just get -1. Imaginary numbers often come in a form called complex numbers. And a complex number is something that has both a real and imaginary piece. So A right here is my real piece, and BI is my imaginary piece. So A is real, BI is the imaginary. So complex numbers are equivalent if and only if this happens. So if I have A plus BI and C plus DI, those two things, A plus BI equals C plus DI, IFF means if and only if. A has to equal C and B has to equal D. So A has to equal C, B has to equal D. We often write imaginary numbers in what we call standard form. Standard form is A plus BI. So let's talk some more about them. So if you remember back to one of the review sections, we looked at categorizing numbers: natural, whole, integers, rational, real, irrational. But there's a whole nother side over here that we never talked about. This side over here, the non-real complex. Because inside of the complex numbers, we have these imaginaries. And when you put an imaginary piece with a real piece, we can make complex numbers. So we can rewrite roots to get rid of the negative. For example, if I had the square root of -5, we can call that the square root of -1 times the square root of 5, because they live in the same house, so -1 times 5 would make my -5. And then on the previous page, we talked about how the square root of -1 is called I, so we would write this as I root 5. So let's do some more of these examples. So if we start with letter A, I'm going to rewrite this as the square root of -1 times the square root of 16. Square root of 16 is 4, and the square root of -1 we call I, and then we write the number first, so 4I. Letter B, square root of -1, square root of 70. 70 doesn't simplify into anything nicer, so we just call this I root 70. When we have a whole number, not a root, we put the real number or the whole number first. But in this case, we write the square root second, so we don't think the I is under the root. This is going to be the square root of -1, square root of 48. And let's just go over here in case you forgot how to do this. Make some space. So, oops. 48. I know that 48 is 3 times 16, and 16 is really helpful, but in case you didn't know that, maybe you did 6 and 8. Well, 6 breaks down into 3 times 2, and 8 breaks down into 2 times 4. 3 is prime, 2 is prime, 2 is prime, but 4 becomes 2 and 2, which are then prime. And we're going to take the square root, which means you have to make a pair for one to come out. So here's a pair, so 1, 2 gets to pop out. Here's another pair, so another 2 gets to pop out. And 2 times 2 is 4, so I get 4 root 3. I'm going to go back up here and do it the other way. So I have the square root of -1. I told you that 48 was the square root of 16, or 16 times 3. The square root of -1 is called I. Square root of 16 is 4. Root 3 is just root 3. And then we write this in order. 4I root 3. Which is the same thing we got down here. So either way works. So we're going to, let's read this caution up top. So when you're combining, just make sure that you're very careful. When things live in the same radical, you know that you can multiply them together. But if we have the square root of a negative number, we always want to pull that I out. And then we can multiply the 4, and for the 9, it'd be I root 9. We always want to pull that I out before combining things inside the radical. So let's keep that in mind, and let's try a couple. So letter A, it's going to be I root 7 times I root 7. I times I is called I squared. And then the square root of 7 and 7 can go in the same house, which is going to be the square root of 49, which is just 7. So I have I squared times 7. I squared is -1, which was talked about on the very first page. So this is the same thing as -7. Let's try another one. So letter B, pull out the I, square root of 6. Pull out the I, square root of 10. I times I is going to make I squared. And then I have the square root of 60. I squared, 60 is 4 times 15. The square root of 4 is 2. So this is going to be I squared times 2 root 15. I squared is -1, so this is -2 square root of 15. Let me scroll down. Okay, letter C. On top, I get the I, and the square root of 20 is 4 times 5. On the bottom, I get I, and then the square root of 2. This is, the square root of 4 is 2, and then the I and the root 5 all over I root 2. This I and this I are going to cancel off. So I have 2 root 5 over root 2. And then I cannot leave it like that. So you have to multiply or rationalize by square root of 2 over the square root of 2. We don't leave roots in the bottom. So it's going to get 2 root 10. And these 2 is going to be the square root of 2 squared. So it's going to be a 2. And then these 2's cancel off. So I'm left with the square root of 10. Now letter D is a little bit different because only one of them is the square root of a negative. And so since only one of them has a negative under the radical, we can actually not pull the I out at first, which makes things a lot easier. So I'm going to write this -48 over 24. They're both square rooted, so I can write it as one fraction. This equals 24 goes into 48 twice. It's going to be a -2. Then I can't leave the negative under the roots. This is really called an I root 2. So it's only if they both have a negative, but this one didn't have it. But if you go back up to like letter C, they both had that negative sign you had to deal with. So let's rewrite this given problem in standard form. Remember, standard form is this A plus BI form. So to get there, I'm going to break the fraction apart. They both have to get divided by 4. So I get -8 over 4 plus square root of negative 128 over 4. I can't leave the negative there, so let's write this again. Negative 8 over 4 plus, gotta pull the I out, and 28 can be called 64 times 2 over 4. I can rewrite this, negative 8 over 4 plus I. The square root of 64 is 8, and then root 2 all over 4, and then I'm going to simplify. Negative 8 divided by 4 is negative 2, plus 8 divided by 4 is a 2I root 2. So there is your simplified version. So we're going to do some math down here with complex numbers. When you're adding and subtracting complex numbers, I need you to think of the I as like an x, like a variable. And so you only put I stuff back together with I stuff. So let's write this. This is 3 minus 4I plus negative 2 plus 6I. Real goes with real, so I get 1. Imaginary goes with imaginary, so I get plus 2I. That's my answer. Let's try again. This time we have to remember to distribute the negative into the parentheses. So we get negative 4 plus 3I minus 6 plus 7I. Real goes with real, so you get negative 10. Imaginary goes with imaginary, so you get plus 10I. There's your answer. On these pages we are going to, or on these problems I should say, we're going to FOIL. So 2 times 3 is 6. 2 times 4I is a plus 8I. Negative 3 times 3 is a negative 9I, and then negative 3 times a positive 4I makes a minus 12I squared. I squared is the same thing as negative 1, so this piece is really a negative 12 times a negative 1, which makes a positive 12. So I have 6 plus 8I minus 9I plus 12. 6 plus 12, those are real pieces, is 18. And then 8I minus 9I is just minus an I. Pretty sure there's a problem like this on a quiz or a test somewhere, so make sure you pay attention to letter B. 4 plus 3I squared means 4 plus 3I times 4 plus 3I. And now this problem is just like the first one. You just need to know that square means it happens twice. So you do 4 times 4 and then 4 times 3I. So 4 times 4 is 16. 4 times 3I makes a plus 12I. 3I times 4 and then 3I times 3I. So 3I times 4 is plus 12I. 3I times 3I makes a plus 9I squared. This right here, remember that I squared is a negative 1, so this is really a minus a 9. So I have 16 plus 12I, 12I plus 12I. Real and real, 16 minus 9 is 7. 12I plus 12I is plus 24I. These two are something very special. They're called complex conjugates. So when we say conjugates, really all we're changing is the sign right here in the middle. So these are conjugates because they have the exact same 6, 5I, 6, 5I. But the only difference is we've changed the plus to a minus. And they're called complex because these are complex numbers. They're A plus BI form. So 6 times 6 is going to make a 36. 6 times negative 5I makes a negative 30I. 5I times 6 is a plus 30I. And then 5I times negative 5I is a negative 25I squared. The beauty of conjugates is that the middle part cancels out. So negative 30i and positive 30i cancel out. This is a minus 25, and then I squared is negative 1. This is really 36 plus 25, which is 61. And technically, if I was going to write the answer in standard form with the directions said, I would write I'd write 61 plus 0i, because there was no i's in my final answer. Okay, so like I was talking about on the previous page, complex conjugates. We noticed that middle I term canceled out. So if you have complex conjugates, and again, the real and the real, the imaginary and the imaginary, and the only difference is the sign in the middle. When you FOIL them together, you're always going to get a squared plus b squared. So that's important, because when I go to do letter A, if you remember, I equals the square root of negative 1, but we also don't leave roots in the denominator. So this I right here is a problem because it's a root. So I can get rid of it by using this idea of a complex conjugate. I'm going to multiply the top and the bottom of this fraction by the complex conjugate of the denominator. 5 plus I over 5 plus I. Since this is the same top and bottom, it's like multiplying by 1. So I'm not changing anything. So now I have to FOIL the top and the bottom. So on top, 3 times 5 is 15. 3 times I is 3i. 2i times 5 is 10i. And 2i times I is going to be a plus 2i squared. In the denominator, 5 times 5, 5 times I, negative I times 5, and negative I times positive I. Or you can know that they're conjugates, and it should come out to 5 squared plus that I has a 1 in it, so it'd be 5 plus 1, or 26. But we're going to do the math. So 5 times 5 is 25. 5 times I is called 5i. Negative I times 5 is negative 5i. And negative I times positive I is going to be negative I squared. This right here, I squared is negative 1, so this is a negative 2. And an I squared is negative 1 plus a negative in front makes this a positive 1. So what I really have now is 15 plus 3i plus 10i minus 2 over 25. Those two cancel out, so I have 25 plus 1. So on top, 15 minus 2 is going to be 13 plus 13i all over 26. And in a prior problem, we separated the fraction. So we get 13 over 26 plus 13 over 26i, which simplifies into 1/2 plus 1/2 I. And there is my final answer. Letter B, conjugate. Okay, so first of all, this thing is like 0 plus I. So you can multiply by the conjugate top and bottom if you want to. Or you can just multiply by an I over an I. This is a special case. But if you want to go ahead and FOIL out, you could do 0 plus I over 0 plus I. It will work out too. It's just a lot longer. 3 times I is called 3i. On bottom, I times I is called I squared. I squared is negative 1, so 3 divided by negative 1 is a negative 3i. Okay, the last thing we'll talk about is reducing i's to a very large power, and so I want to draw a little picture or something that I have always used, and hopefully it'll help you. So let me write it first, and then we'll use it. So we're going to talk about remainders. So I can have a remainder. I can have a remainder of 0, a remainder of 1, remainder of 2, or a remainder of 3. So this is like saying I to the 0th power. This is like saying I to the 1st power. This is like saying I to the 2nd power. And this is like saying I to the 3rd power. Anything to the 0th power is 1. I to the 1st is just I. I squared we know is negative 1. And then this I to the 3rd, I to the third is the same thing as I squared times I. I squared is -1 times I, so I to the third is the same thing as saying negative I. So I'm going to use that picture to do these problems. So the first one, all you should do is long division. There's 4 things in the pattern, 1, 2, 3, 4. And after that, they just repeat themselves again. So I'm going to take 15 and I'm going to divide, yes, long divide, old school long divide. I'm going to long divide by 4. So 4 goes into 15 3 times. 4 times 3 is 12 with a remainder of 3, So what that means is I went around the circle, or through the cycle. I went through the cycle 3 times. 1, 2, 3, and then I went a remainder of 3. So remainder of 1, remainder of 2, remainder of 3 right here. So I to the 15th is the same thing as I to the third power. So really all you're doing is finding the remainder and putting I to that power. The one down here, I'm going to do it 2 ways. I'm going to do it the way I did it, and then I found a trick to do it. So I can take that negative exponent and put it on the bottom, I to the third. And then if you remember in a previous section, we talked about like you have to multiply by what you're missing. So I'm missing down here, I need 1 more I. So this would get me I on top. On the bottom, it would get me I to the fourth. And I to the fourth is the same thing as 1. So I just get I. The other way you can do this is do I to the negative third. And I want to multiply by 1. Well, right here, here's a 1. And that's the same thing as saying I to the fourth. Oops, sorry, I put a 0. I to the fourth, not 0. So I can do I to the negative 3 times I to the fourth. Then you just add these powers, and you get I to the first, which is the same thing as I, which is what we got down here. So either way works. So crash course in imaginary numbers. Hopefully you kind of remember them from Algebra 2, because we're going towards that quadratic formula next section with I's and having no real solutions.